So chapter 3, part 1 review, and this was covering distance, displacement, speed, and velocity. So number 10, what is the difference between uniform and non-uniform motion? First question, classify each of these as uniform or non-uniform motion below. 1, a rubber stopper is dropped from your raised hand to the floor. That would be non-uniform. Second, a car is traveling at a steady rate of 85 kilometers per hour due west. That's uniform. Third one, a rocket begins rising from the launch pad. That is non-uniform. Number 4, a motorcycle rider applies the brakes to come to a stop. That would be non-uniform. 9, what is the difference between a vector and a scalar? Be able to identify examples. So a vector is described by magnitude and direction. A scalar is described by magnitude only. Examples identifying the following. We've got 30 newtons to the right is a vector. 40 meters per second is a scalar. Speed is a scalar. 10 seconds is a scalar. Distance is a scalar. 20 meters per second squared north is a vector. Velocity is a vector. 2 cups is a scalar. Displacement is a vector. Acceleration is a vector. 20 meters is a scalar, and 12 books is a scalar. Number 8, calculate distance and displacement for various scenarios. So if you walk from your house to your friend's house 5 kilometers away, what is your distance? It's 5 kilometers. What is your displacement? Oh, it has to be 5 kilometers in some direction. I am calling it north. Second part, if you walk from your house to your friend's house 5 kilometers away and then return home, what is your distance? 10 kilometers. What is your displacement? 0, because you start and end in the same spot. Third question, if you travel to a store that's 15 kilometers north of your house and then return towards home, but only go 10 kilometers before stopping for ice cream, what is your distance? You traveled 25 kilometers. What is your displacement? 5 kilometers north, because you ended 5 kilometers north of your home because you stopped to get ice cream. Number 7, know the formula for speed and be able to rearrange it. What is the formula for speed? Speed equals distance over time. And can you rearrange it for the other terms to find for distance and time? Number 6, use the formula for speed to calculate any of the terms. So when you have a speed of an object that travels 20 kilometers in 10 minutes, speed equals distance divided by time. So you will solve for that and get 2 kilometers per minute. What is the distance traveled by a vehicle traveling at 70 miles per hour for 4.5 hours? You end up with distance equals speed times time. 70 miles per hour times 4.5 hours, and that is 315 miles. How long will it take you to reach a destination that is 400 miles away if your average speed is 50 miles per hour? Time is distance divided by speed, so 400 miles divided by 50 miles per hour will give you 8 hours. Number 5, know how to calculate speed and velocity. So if you walk from your friend's house to your friend's house 5 kilometers away in an hour, and it happens to be north of your home, what is your speed? 5 kilometers in an hour means 5 kilometers per hour. What is your velocity? 5 kilometers per hour north. If you walk from your house to your friend's house 5 kilometers away to the north and then return home in 1.5 hours, what is your speed? You traveled 10 kilometers and you did that in 1.5 hours, so that gives you a speed of 6.7 kilometers per hour, and your velocity is 0 because you started and ended at the same place. If you travel to a store that is 15 kilometers north of your house and takes 30 minutes, and then return towards home but only go 10 kilometers before stopping for ice cream, and that takes 15 minutes, your speed is 25 kilometers divided by 45 minutes, and that gives you 0.56 kilometers per minute. Your velocity is 5 kilometers north divided by 45 minutes, so you end up with 0.11 kilometers per minute north. Number 4, know the difference between speed and velocity and apply it to problems and conceptual descriptions. If a car moves with constant velocity, does it also move with constant speed? Explain. Yes. Yes, because velocity is speed in a constant direction. However, if a car moves with constant speed, does it also move with constant Velocity, explain. No, because constant speed does not have to be in a straight line, whereas constant velocity does. 3, understand the concepts of displacement and distance to problems from the MOP app. 3, understand the concepts of distance and displacement to problems from the MOP app. So Grandma Henderson challenges Michael Johnson in the 400-meter dash. Grandma H spins her wheelchair 5 times and gives up 15 meters from the starting line. MJ makes a complete circle around the track and stops at the starting line. In this race, who has the greatest displacement, or are they the same? Grandma has the greatest displacement because she is farthest away from the starting point. At Michael Johnson's displacement is 0 because he starts and stops at the end at the same point. So if we replace the word displacement with the word distance, would you end up with the same answer? Why or why not? They're not going to be the same. It would now be MJ because he went an entire 400 meters around the track and Grandma only went 15. Number 2, understand the concepts of distance and displacement to problems from the MOP app. So the football coach walks along and he does this whole little walking from A to B, B to C, C to D, and D to E, and you're asked to find his entire distance. So from A to B, he went 30 yards. From B to C, he went 40 yards. From C to D, he went 50 yards. And from D to E, he went 25 yards. So his total is 145 yards. It's distance, so you do not need a direction. If we replace the word distance with the word displacement, is the answer the same? No, it's not going to be the same because now we're only going to compare points A and E. E is 15 yards east of A, so our displacement is going to be 15 yards east. And the last part, understand the concepts of average speed and average velocity to problems from the MOP app. So the teacher walks this following motion: 2 meters south, 4 meters east, 2 meters north, and 4 meters west. What is the teacher's average speed? Well, the average speed is distance divided by time. The teacher covers 2 plus 4 plus 2 plus 4, which is 12 meters in 10 seconds. So that would be 1.2 meters per second. If we replace the words average speed with average velocity, is the answer the same? Why or not? Why not? Well, the teacher is going to start and end at the same location. So their velocity equals distance over time, or displacement over time, sorry. And displacement equals 0, so their velocity equals 0. So that is the top 10 points for Chapter 3, Part 2.